Okay, for us today in Math 2, we're going to have to go back and review some exponent rules that you learned back in Math 1. To begin with, I'd like to focus on using our calculator to do this first set so that we can kind of see what's going on and why we might need to learn these rules. And so as we look at this, I'm going to try to pull my calculator up beside it so we can type on the calculator as well as see the questions. So so in looking at this first question, 3 to the negative 2, I'm going to type that in my calculator. 3 power key negative 2. And what I notice is it comes out a decimal. Now, nothing on this worksheet is going to be a decimal. So I need to math frac that. Math frac, enter, and I get 1/9. Now, let's discuss that a minute. Because that kind of looks familiar. Like 3 squared is 9. Why did it end up being on the bottom? Because that seems really odd. Well, let's try that again. Maybe it doesn't do that every time. So we'll go back to our calculator. Let's try typing number 2 in. So number 2 says 2 to the negative 4. And again, I got a decimal, so let me math frac it. And I got 1/16. I wonder if 2 to the 4th is 16. Let me check that out. 2 to the 4th without the negative on it is 16. So what do you think the negative's doing? And that's right, the negative's making it move to the denominator. So a negative power makes it move to the denominator. That's interesting. So now in our next example, we have negative 4 to the 0 power. So negative 4 to the 0 power. Came out negative 1. Well, the negative was outside, so that makes it interesting why it came out negative. And 0 power. I guess anything to the 0 power must be 1. And then the negative just came down based on that. So in our next question, we have a negative and a positive power. Let's kind of see what happens with that. So we have 4 to the negative 7 times 4 to the 2nd. Math frac. And we end up with 1/1024. 1/1024. Wonder how many 4s it takes to make that. Because over here, 2 3s made 9 and it went down because it was negative. 4 2s made 16, it was negative. Just wonder what makes that. Let me see. We know 4 squared is 16. 4 to the 3rd is 64. 4 to the, well, I got the wrong key there. Oh, I did it again. Caret key, yeah, there we go. To the 4th is that. 4 to the 5th. Oh, wait a minute. There wasn't no 5th in my problem. How does 4 to the 5th come out to be that? Well, if we take into consideration what we talked about 4 and put that down, that might make sense. We'll look at that more in a little bit. So, I wonder what happens when you do some of these questions. For example, what happens if there's a negative power inside and a negative number? Will it come out negative? Will it move down? What will it do? Well, let's see. Parentheses negative 2 to the power of negative 4, parentheses to the 5th. Math frac. Well, that won't frac. What am I going to do? I think I'll leave one of the negatives out and see if I can get it that way. Let's leave the negative power out and see if we can get it. Okay. So the negative power is going to make it move down. Well, I can't write the number down if it goes away. 10, 48, 57. 10, 48, 57, 6. So first of all, where'd that negative go? Because negative 2, yeah, it's negative. So the negative on the outside of the 2 makes the whole thing negative. And this piece here made it come down so that it would work out the denominator. So here, because they're both negative, why don't I move them both down and just work out 7 to the 8th and 7 to the 5th in my calculator on the denominator only. Because I can't type that in the way it is, it won't work it. The powers are too high. Well, that one's too high anyway. So, in this problem, if I have 8 7s and 5 7s, I've got 13 7s, and I can't write that number out. It's way too big. It's scientific notation, so I'll just leave it like that. And what happens if you have 2 to the 3rd? Well, before I do that, let me type that in the calculator. 2 to the 3rd times 2 to the negative 3rd. Oh, wait a minute, that came out 1. Well, because if you move that one down, anything divided by itself is 1. That makes sense. All right, let's try this last one. I'm going to move my calculator over just a wee bit. I hate it when it does that. Alright, so negative 3 to the negative 2 power times 1 divided by 2 to the negative 2. Math frac. Alright, so let's see, why does this come out to be negative 4 over 9? Well, first of all, this 2 squares going up to become a positive power. And this 3 squares going down to be a negative power changed to a positive power. That's how 3 squared ended up with 9 on the bottom, and 2 squared ended up with 4 on the top. And the negative just stays on the outside. So as you can see, you can't just type all these in the calculator. The calculator's not smart enough sometimes to figure it out without math frac, or we're just moving the powers around so that you can work with positive powers and only work out maybe just the numerator or just the denominator. So now stop the video and do the independent practice problems and see how many of these you can work out yourself using the calculator. First try typing it in just like it looks, and if that doesn't work to math frac, then back up and move some negative powers around and see if that'll work. Now at the bottom of the page there's some rules that we're going to kind of go back and do some more with. And we have clarified a little bit of this already, because first of all, anything to the 0 power. Anything to the 0 power is 1, no matter what variable it is. If it's x, y, z, q, 3 to the 0 power is 1. Anything to the 0 power is 1. So if that's the case, then 3 times 1 is 3. If you have a bunch of terms, just throw the 0 power away and write down what's left. It's that simple. And it doesn't matter where the 0 power part is in the problem, whether it's first or last or in the middle. 0 powers make it go away. So that's the rule for 0 powers. For negative powers, you move across the divide line. Now, if it's on top, you move it down, and if it's on bottom, you move it up. So because of that, in this first one, I'm going to move it down because there's no bottom, and that's going to drop the negative off the 2. But notice I didn't take the 4 with it. I only took the part that had the exponential negative part. So in our next one, this is the only one that's negative. So everyone else is going to stay on top, and you're going to move your negative power down and make it a positive power. That's the whole point. Moving across the divide line, change to positive exponent is the whole point to this process. Now, in this next part, the only thing that has a negative exponent is z to the negative fifth. This negative 2 out here does not move because it's negative. That's a coefficient. We're moving negative exponents across that line. So negative 2, y to the fourth is staying on top, and z to the fifth is going down to become a positive z to the fifth. Now, in these next few examples, we have a parentheses problem. And I'm probably going to need to write these on the opposite side because I'm running out of room on the other side. But when I look inside my parentheses, nothing needs fixing. You've got a coefficient of negative 3 and 2 positive power problems. But the whole entire thing is a negative power problem. So the whole entire thing is going to move down and become to the positive 1 power. And I don't need a positive 1 power. I'd have kept the parentheses if that was any other number outside, but since I've turned it to a positive 1, I can write it down, but I don't really need it because anything to the positive 1 power is the same thing. Now in this next question, I see a 0 power that I need to throw away, and I see this y to the third needs to come down before dealing with the power on the outside. You should clean up the whole entire inside. So since the entire thing is to a negative power, everybody on bottom is moving across the division line. Everybody on top is too. They're switching positions so that everybody had to move since everybody's to the negative 1 power. And I don't need to write that in parentheses to the positive 1 power because that's going to go away. So if I move this x to the third down, then my whole entire problem looks like this. Now that negative 2 doesn't move because it's negative. It's a coefficient. I only move things because they're to a negative power. So that's why I moved x to the negative 3 down, because it was to a negative power. But now the whole entire problem needs moving. So you're going to flip-flop the two sides because the outside is negative. Everybody moves across the division line, and that drops the negative power on the outside. And since that negative power is 1, I can drop the whole entire parentheses set. So that's a review of 0 powers and negative powers. So on our next page, we're going to guide you through how to deal with multiplying two sets of information together. And I have listed here, possibly we might need 4 steps. So let's start writing some steps. So first, step 1 is to move negative exponents. You want to get rid of all your negative exponents first. You don't want to have any negative exponents. So in this problem set, I'm going to move these z's down, and I'm going to move these x's down. And now I've got that kind of organized. Step 2 is to reorder by types. And what that means is put things of like type is like put the two coefficients together. They're both on the top. Look at where your x's are. I've got x to the third on top in this first one, and I have an x to the fourth on the top in the on the bottom, on the second one. Look at your y's. You got y to the fourth and y to the fifth both on top. Look at your z's. You got z to the sixth and z to the third is on the bottom. Organize it by type, because you want to be able to see the coefficients together, the x's together, the y's together. But you also want to keep the integrity of, is it on the numerator or denominator, because you've moved your negatives. Now you get to multiply coefficients. So when I multiply negative 2 and 3, you get negative 6. And then you want to deal with your variables. And the multiplying rule is you multiply rule is you add exponents. because I've turned this into some division, I'll go ahead and list the division rule. Is you subtract exponents. And I always think of this as getting married and getting divorced. If I'm getting married, we're going to put all my money in one bank account, so we're going to add all our money together like these Y's are going to do. But if I'm getting divorced, I've got to separate my money away from the gentleman that I don't want to be married to anymore, and we want two separate bank accounts, so I subtract my money out. And so here in my x's, I need to subtract. Now I always do the bigger minus the smaller, so 4 minus 3 is 1. And if you don't think about it like that, you could think of it like this. I have 3 x's, and I have 4 x's, and 3 of them are going to cancel out. So that's why 4 minus 3 leaves me with 1 x, but it'll be on the bottom because there are more on the bottom. Now I'm not going to do that like I did with these x's every time. I just wanted to show you why it's subtraction, because you've got to take away when there's some on top and bottom, they cancel out. Now all my y's are on the top, so if I have 4 y's in one pile and 5 y's in the other pile, I'm going to add them together because they're both on top. And that'll be y to the 9th. Then with the z's, since it's on top and bottom, we're going to subtract. Again, you take the biggest minus the smallest, so 6 minus 3 is 3, and put it back where there are more, which means I'm going to put them back on top. So when you subtract, put back where more. All right. So now let's look at question number 2. So over here, I need to move these x's down because they're negative, and I need to move this y to the 3rd down because it's negative. But I am not moving negative 3, the number, down because that's a coefficient. You only move negative power problems down, so they'll drop that negative power. So let's regroup our problem by type. 5 times negative 3. And your x's, there aren't any in that one over there, so there's just some x squared on the bottom of the first one. And y's, I have y to the 4th on top and y to the 3rd on the bottom from the 2 different ones. And z's, there's only one z term and it's on top. So once I put all this together, I'm going to multiply my coefficients, and I'm going to see what I need to do with the powers. There's only one x term, so it stays on the bottom. Y's are in division, so I subtract and get 1y, because 4 minus 3 is 1. And z stay on top because there's only one term of z. And that's the answer to question number 2. It can't be reduced any further than that. So in question number 3, I'm looking for, okay, these y's need to come down because that's a negative power. Over here, these x's and y's need to come down. We're at y. The x's are going to come down and become x to the 3rd, and the y's are going to come down and become y to the 5th. So get rid of your negative powers first, then reorganize. 2 and 4 are both coefficients. You've got an x to the 7th on the top and an x to the 3rd on the bottom. You've got 2 y terms and they're both on the bottom. So once you reorganize, you're supposed to multiply the coefficients, which makes 8. And my x's are being divided, so I'm going to subtract. 7 minus 3 is 4, and I'm putting it back on top because there were more on top when I started. My 2 y's are side by side. That means they're multiplied. Therefore, I add those powers together, and it's still going to be on the bottom because they were on the bottom in the first place, and 3 and 5 make 8. So over here, my negative 6, I can't do anything about that. 4 I can't do anything about because it's positive, but this y I can bring down and make it positive power. 0 powers drop off. Let's reorganize it by type. So the 2 negative numbers are both coefficients. You have x to the 4th, and there are no other x's left since the 0 power dropped out. And y to the 4th over y to the 2nd organizes my y's. So negative times negative makes a positive 42. X to the 4th is staying. Y to the 4th over y squared is going to subtract. 4 minus 2 is 2, and I'm putting it back on top. Therefore, I don't really need a denominator because nothing ended up being in the denominator. So I take that away and just have what would have been in the numerator. So sometimes you don't end up with fractions at the end, depending on what you're working with. They may subtract totally out and give you just a numerator. So here are 4 for you to try, so stop the video and try these 4, and before we move on to looking at problems that are already written as division. See, all of these are written as multiplication, but sometimes division gets introduced by moving the negative powers. Now, when you start looking at question number 7, remember that this is a -1 in front. That negative is not on the x. So when you move that x to the -2 down, make sure you keep that in mind. Well, it's time now to look at problems that are written in division form. It looks like I have 5 steps here. So let me take the steps that we have on the previous one and copy those back over and see if we can reuse any of those. Well, okay, that was weird. Okay, as always, one of the most important things to do is to move your negative exponents. So we are still going to be doing that first. So in question number 1, I'm going to move these y's down and make them squared. So that's still going to be really important. Now, a lot of these problems are already grouped, so I don't think we need to reorder by types because they're already grouped up really nicely. So moving that negative power makes it look like multiply or divide. So I don't need this step like I used before. Now, next, we're going to look at, I don't have multiplying coefficients anymore because they're not side by side, they're up and down. So I'm not going to need that rule. So what am I going to do instead with these coefficients? Well, for one thing, they look like they might reduce. So we're going to reduce coefficients if they look like they will reduce because they're up and down in the numerator and denominator. So therefore, 5 goes in that 3 times, 5 goes in this 5 times. So next, I think we can focus on the multiplying and dividing rules are going to be what you want to work with next. It's not like you do these two separately. You really are doing them kind of together when you get to them. But I'm just going to list them as separate rules, but you're going to do multiplying and dividing depending on what you get to. So far in this problem, we already have 3 and 5 have been reduced, and that negative needs to go to the top because you don't want to leave a negative in the denominator. So now we have to pick and choose between multiply and divide rules. So since the x's look like they're on top and bottom, I need to subtract the powers because that's division. 3 minus 2 is 1. There are more on the top, so I'm going to leave 1x on top. Now you can write that 1 up there as a power or not. That's up to you. But on the y's, they're side by side, meaning multiplied, so I need to add the powers and put it back where they are. So that adds up to 5 for the power, and I put it back on the bottom because there were more. And then sometimes I'm sure there'll be some other things we need to think about in these problems. Maybe where the negative is might be a thought, or there may be something else I just haven't thought of yet that this 5th rule will be. But I'm thinking it is make sure the negative coefficient is on top. If we need to come back and put something later from another problem, we'll do so. So over here, I look at the coefficients. The negative's already on top. That's C, so that's not going to always be a rule I need to worry about. So move negative exponents is always the first step. So we're going to move y to the 7th to the bottom, and we're going to move x to the 3rd to the top. Step 2 says reduce coefficients in the numerator and denominator, and negative 2/3 doesn't reduce. So I skip that step. Step 3 and 4 are done simultaneously. So x to the 4th and x to the 3rd are side by side. So we're going to add those two together. Y to the 7th and y to the 1st are side by side. You might even want to write that one in so that you can remember that's to the 1st. That makes 8 y's on the bottom. But on the end here, I've got division, and 4 minus 2 is 2, and I put it back where there are more. Now be careful. It's not 2 minus 4 is negative 2, because if you get a negative, you're going to have to move it down and turn it into a positive. So it's just best to do biggest minus smallest, put it back where there are more. Alright, so I'm going to do maybe one more for you so that if in these problems you can just see a variety of different things. And I think I'll do number 4 because it has a little bit of difference to it compared to the others I see here. And then you can do the other 3. So in this question, step 1 is to move your negative powers. So I'm going to move these y to the 3rd up and the z to the 3rd down. And also, let's go back and add something to our rules. Move negative powers and drop 0 powers. Yeah, we don't want to keep any 0 powers, so that's part of step 1. You do that all at one time. So I'm going to throw away this 0 power. Now I'm supposed to reduce the coefficients, so 32 and 24 are both divisible by 8 to make 4 over 3, and 2 negatives cancel to make a positive in division, so I can just drop the negatives if you have 2 of them on the coefficients. Now my x's in this question are numerator and denominator, so I need to subtract. 7 minus 3 is going to give me x to the 4th on the bottom because there are more on the bottom. I've already thrown away the 0 power for y, so I only have y to the 3rd on top for y's. And z, I've got 2 z's on the bottom, one's to the 4th and one's to the 3rd, so that adds up to 7. So now stop the video and work these 3 questions and see if you can follow through the rules and get these 3 worked using those steps that we just discussed. Well, in our next steps, we've got to make sure that we're doing power-to-power rules, and in some of these power-to-power rules, we're going to continue to use some of the rules we've already done, but at the same time, we've got to come up with what makes the power-to-the-power part work. So we want to clean up all of our powers. We want to have all positive powers, and we want to have, on the outside and the inside, all positive powers. So we're going to move negative powers inside or drop 0 powers inside. Very important to do all that inside work first. But then we want to focus on the outside, and we want to move all terms if negative outside, or what if the outside is 0? We should probably think about that as well. So we're going to move all terms if it's negative on the outside, or we're going to drop all terms if 0, which makes the answer to the question 1. Okay. So let's start off with these rules, and then we'll kind of see where we can go from there. All right, so we're going to look at these rules and see where we can take it from there. So the rule said if there's a negative power inside, move it. So I'm going to move this one down and make it to the positive fifth power. That makes my parentheses still around the whole entire thing. I don't have any zero powers in there. So then I go to the outside. I don't have a negative power or a zero power outside. So I've completed everything I can think of for step 1 and 2. So now we're going to, for step 3, put the outside power on each part. And what that means is you're going to say negative 2 to the third power, x to the fourth to the third power, z to the second to the third power, and y to the fifth to the third power. So you're going to put it on each one individually. And then step 4, you're going to work the coefficient on the calculator, if you need to work out that power problem. And step 5 is you're going to multiply powers on the variable terms. Now let me try that a little bit cleaner. Variable terms. So in this problem, negative 2 to the third power, if we type that in the calculator, it comes out negative 8. X to the fourth to the third means we're going to multiply those. Think of it like something's up against a parentheses is always distributed, and distributive means multiply. So 4 times 3 is to the 12th. Here with the z's, I have 2 times 3, which will be to the 6th. And here on the bottom, I have y to the 5th to the 3rd, so that's going to be to the 15th. Now, I could probably just demonstrate this better, long ways, with writing this one out, just so you'll understand why. So what it says here is you have z squared 3 times. Z squared, z squared, z squared. And as you can see, that's 6 z's because you got 2, 2, and 2. And so that's why it's kind of like you've got 3 sets of 2, which is why it's multiplied together. So it's a lot easier to multiply that out than it is to write it longhand. So let's look now at the next question. And going back to our rules, it says move anything in the inside that's negative. So I'm going to move this x squared down and make him to the positive power. Then it says move anything on the outside that's negative. Because I don't see any zero powers in this one, that makes everybody move. X squared is going to the top, 3y, 7z is going to the bottom, and that makes the power on the outside positive because you've moved everybody. You've flip-flopped the entire fraction, causing the power on the outside to turn positive. Then you distribute your power to each one. So you're going to have x squared squared on the top, 3 squared, y to the 7th squared, z squared. You're going to work the coefficient on the calculator if you didn't know what 3 squared was, which I do, so I'm going to put 9. X squared to the 7th means multiply the powers and get to the 14th. Y squared to the 7th to the squared is going, I didn't do that right. I can't read my own handwriting. That's a 2. X squared squared is going to be to the 4th. Y to the 7th squared is going to multiply those and give y to the 14th. And z doesn't have a power, so we assume it's a 1. So 1 times 2 is 2. So there is my final answer to this question. Okay. I'm going to do a couple more for you. I just wanted to go back to that page to see how many more there were for you. So here in our next step, we have a negative power on the inside that needs to come down. That makes our parentheses around the whole thing. There are no zero powers there. But there is a negative power on the outside that's going to flip the whole problem over to make that negative power become a positive power. Now I've got to redistribute my powers. So I am going to say x to the fourth over negative 3 to the fourth, y to the fourth, z to the third to the fourth, so that we can work the question out. So the parentheses is between the two powers means to multiply them. We have negative 3 to the fourth that you might want to go type on the calculator, which is 81. Y to the 1 to the fourth is going to be to the fourth because you multiply 1 times 4 and get 4. And 3 times 4 is 12. So this is why you want to get everything organized. It makes it so quick to finish the question. Now in this last problem, if I move this negative power down and make it y squared, it will make absolutely no difference because the whole entire problem is to the zero power, so the whole entire answer drops away and becomes 1 because anything to the zero power is 1. So it doesn't matter if I have 100 things in there or I have 1. 7 to the 0 is 1. X to the 0 is 1. So since 3 times 0 is 0, so z to the 0 is 1. Y squared times 0 is 0. So y to 0 is going to be 1. Everything's going to be at 0 power, so everything's going to be 1. So anytime you have a 0 on the outside, that makes it really easy. So continue by stopping the video, and well, actually this is going to be the end of the video. You're going to try 4 more questions, and then you have a page to do for homework.